Okay, hopefully this is recording, Liv. Sorry you're not well, but let's go through a few of these questions. I'll start with question 9, see if I can get that one saved, and then I'll try and send some others on. So this is a pretty standard question, and question 9 is going to be about basically going from an acceleration to a velocity and then to a displacement. So here we've got an open air elevator that is 20 metres above the ground. So I'm just going to draw a quick diagram, 20 metres above the ground. It's rising vertically, so it's going up, and its velocity at time 0 is 10 metres per second. This little 20 metres, I'm going to call that my initial displacement, so S of 0 equals 20. And then they give me one more little bit of information. A hammer is dropped. There's my very fantastic little claw hammer there. Hammer is dropped and it starts accelerating towards the ground. So because it's going down, even though it says G is 10, I'm going to use negative 10 metres per second squared. Because it's travelling down, and I've already defined the ground is like level. And at the ground, I'm going to say S at the ground equals 0. You can write that. I've already sort of defined that with the S of 0 equals 20. If you don't write that last little bit, that's not going to matter either. So what do we have to do? I know that the acceleration at time t is negative 10. So my velocity at time t is the integral of the acceleration. So it's negative 10 dt, which of course becomes negative 10 t plus our constant of integration c. But we know that the velocity at time 0 was 20. When the hammer was dropped, the elevator was going up at, not at 20, it was 10 metres per second. The velocity was 10 metres per second. So therefore, if I replace v of t with a 0, that's negative 10 times 0 plus c. V of 0 equals 10. So I put 10 where v of t is 0 for the actual value of t, and I get that the c value must have been 10. So my velocity at time t is equal to negative 10t plus 10. Now, we want to determine the time taken for the hammer to hit the ground. So I'm going to have to figure out what time it was when the displacement was 0. So I guess I've got to figure out my displacement. So S of t is going to be the integral of the velocity. So the integral of negative 10t plus 10, which is going to be negative 5t squared plus 10t plus a new constant. I'm just going to call it C1. You could call it D. Probably don't call it C again because we've already got a C. And we know that at the start, when the hammer was dropped, when the time was 0, at the start, it was 20 metres above the ground. And so when I substitute in 20 for the displacement and 0 for t, I get C1 equals 20. So my displacement equation, negative 5t squared plus 10t plus 20. And now I want to solve for where it hit the ground. Is it going to let me insert space on this one? I can't see where it's going to let me insert space on this. So I'm just going to go to the side here and we'll keep going. Oh, we'll change pens on. Oh no, there we go. We're still good. So I want to let the displacement equal 0 because that's when the hammer is going to be on the ground. So I'm solving 0 equals negative 5t squared plus 10t plus 20. I can divide everything by negative 5. That's going to make it a lot nicer to solve. And if I try to solve this, I can't find factors of 4 that are going to add to 2, so you can either complete the square or use the quadratic formula. I'm going to complete the square for this one because it looks like a pretty nice one. That first bit all just goes to t minus 1. All squared, minus 4 minus another one is minus 5. Difference of 2 squares. Therefore, the first bracket equals 0. Or the second bracket equals 0. This one's going to give me t equals 1 minus root 5. Or t equals 1 plus root 5. But my t has to be greater than 0. So it must be 1 plus root 5 seconds, because 1 minus root 5, that's a negative time. That doesn't make any sense. Let's just check and make sure. I think that was from the first paper, that one. So we can scroll down and see if we made sense of what was going on there. Question 9. Yeah, and you don't need to have, this was a non-calculator one, so you don't want to have, I don't expect you to find that. And again, look, they've shown you how to do the working for the quadratic formula there. So that should be all good. If you want to try another one that's just like that one, and I recommend you do, you can find one down here. This question 9 is really similar. And this question 9 further down is really similar. So that should give you an idea of those. If we get one of the other ones, let's just have a look and make sure we can do these as well. So 2 boats leave the same jetty at the same time. Boat A travels 2 kilometres an hour on a bearing of 30. So here's my north. I'm going to call this the jetty. 2 kilometres an hour on a bearing of 30. 3 kilometres an hour on a bearing of 120. And 3 hours. So after 3 hours, boat A is going to be 6 kilometres away on a bearing of 30 degrees. Boat B, 3 hours at 3 kilometres is 9 kilometres away. And the whole bearing was 120. If I take away that 30, that must leave this little bit being 90 degrees. And this is where boat B is. And then determine the distance between the boats at this time. Well, you could use your cosine rule, or this one, it's actually a right-angled triangle, so you could just go ahead and use Pythagoras' theorem. But let's pretend, because they may give you one where it's not 90 degrees. So once you've done the conversion, 3 hours at 2 kilometres per hour equals 6 kilometres. If you've just done that and labelled it on the diagram, that's going to be fine. If you didn't, you don't necessarily need to show that working, because I believe you can do it. But if you want to, if you're worried and you just want to make sure if you make a mistake you get the marks, then make sure you just show that working. Let's pretend it wasn't one we could do nicely, so I'm going to go d squared equals 6 squared plus 9 squared minus 2 times 6 times 9 times cosine of 90. 36 plus 81. 12 nines are 108. Oh, but then you do cosine of 90 and you remember from your unit circle that that's 0. So I've got d squared equals 117. So the distance between these two is root 117 kilometres. Just making a note that d had to be greater than 0. So I can reject the negative value, because otherwise I would have had to go plus or minus. But as long as you just make a note that you knew it had to be positive because the distance was positive, then you're all good. So those ones are actually pretty nice, pretty easy. Standard cosine rule. You just have to do like a little bit of a calculation with the speed and time and your cosine rule. This one's another one. So rather than something being dropped, it's just talking about a particle that is initially stationary. So what are we going to get information out of this? There's actually a lot of information in just a very few words here. Initially stationary, so v of 0 equals 0. and it's initially at the origin, S of 0 equals 0. And determine the position of the particle at t equals 3. So I'm looking for S of 3. So I start with my acceleration. Therefore, my velocity at time t is the integral of that, which is going to be 2t squared minus 2t plus c. And then you go v of 0 equals 0. Therefore, I'm going to get c equals 0. So v of t is just the 2t squared minus 2t. And now we can find the displacement. S of t is the integral of that. So there's going to be 2t cubed over 3. 2t squared over 2, that's just going to end up being t squared. And I've got a new constant of integration, and then we were given, or however you want to write it, given that S of 0 equals 0, this tells me that C1 is also equal to 0, therefore S of t is 2t cubed over 3 minus t squared. They've asked me to find S of 3, so I substitute 3 in. 27 divided by 3 is 9, times 2 is 18. 18 minus 9 is 9. Did they have meters? They didn't say what the units were, so just 9 units would be fine. It's probably going to be meters, and then you could write meters, but this one doesn't say, so that's fine. So they're not too bad. Well, here they've got a region turned into a garden bed. The x-axis enclosed. So this function, you can see the intercepts. X-intercepts are going to be x equals 0 or x equals 4, and it's an upside down parabola because if I expand that, you can see it's a negative x squared. So basically, that's a garden bed. And determine the cost of turfing the region. I don't know why they're saying it's rotated conceptually into a garden bed, but whatever. And it's $75 per square metre. So all we've got to do is find the area. So the area is just the integral of that function. I'm going to use the expanded form because it's going to be a little bit easier for me to work with. From 0 to 4. So it's going to become 2x squared minus x cubed over 3. And I'm going to substitute in 4 and 0. 2 times 4 squared minus 4 cubed over 3. And then I subtract what I get when I substitute in 0. Well, when I substitute in 0 for this, it's all 0, so that's nice. So that's 32 minus 64 over 3, which is, what's that, 96 over 3 minus 64 over 3, which is 32 over 3. Said the units were in meters, well it's implied they're in meters. So that's going to be square meters, therefore the cost is 75 times 32 over 3. And if you go 3 into 75, that's 25. 4 25s make 100, and there are 8 lots, 4 and 32, so it's going to be 800. You could do the maths on the side or however you like. And the cost is going to be 800. So it's not too bad. There's a couple there for you to try. Hopefully you can figure them out. Maybe I'll just do one more of these ones. A vertical flare is launched from the top of a cliff. That is 30 metres. And it's launched with an initial velocity of 20 metres per second upwards. So v of 0 equals 20. And again, because I'm shooting from the top of the cliff, we've also got this displacement at time 0 was 30. And now this is just like the very first one we talked through. So my acceleration at time t, they've told me to use negative 10 meters per second squared. You've got to remember that it's negative. Velocity at time t is going to be the integral of that, which is negative 10t plus c. V of 0 equals 20. That tells me that c equals 20. And my velocity at time t is negative 10t plus 20. Now, therefore, my displacement at time t is the integral of this, so negative 10t plus 20 dt, which is negative 5t squared plus 20t plus c, 1, because I've already used a c, and then s of 0 equals 30. When I substitute 0 in for t, I must get 30 equals c1. S of t is negative 5t squared plus 20t plus 30. I want to know when it hits the ground, so I let S of t equals 0. Negative 5t squared plus 20t plus 30. Divide by negative 5. I divided by a negative, so those signs have to change. So that's minus 4t minus 6. Complete the square or the quadratic formula. Difference of two squares. Jumping ahead to write the answer, therefore t minus 2 plus root 10 equals 0, or the other bracket, t minus 2 minus root 10 equals 0. This gives me t equals 2 minus root 10, or t equals 2 plus root 10. T to b. T has to be greater than 0. This tells me that t equals 2 plus root 10 seconds. And you could write a nice little sentence after that. But you're done. Hopefully that helped.